Question 27 on 74C. I've started out looking at this web address on a web page that is linked in my written explanations for 74C. This explains if-then statements, converse, inverse, contrapositive. It really doesn't explain counterexamples, and that's what's important for this question. So let me find this question, and it's over here and here. Okay, there's our answer. And I've got the answer circled, but that doesn't matter. It says, Jamie claims if a triangle is in set A, then it is not isosceles. Now that's an if-then statement. An if-then statement looks like this. If P, the arrow stands for then, if P, then Q. In order to have a counterexample of an if-then statement, you still have to have if P, then not Q. So in other words, if I say, tall people can reach the roof. In order to find a counterexample to prove to you that this is false, I wouldn't go and find some short people, because you'd say, well, now you're talking about short people. You claim that tall people could reach a roof. Now you're talking about short people. So that doesn't tell me that what you said before is false. So I have to still have tall people. If P, if tall people, then they cannot reach the roof. I'm just going to put, for shortness, reach, but cannot reach, well, okay, I'll write roof. You convinced me. Cannot reach the roof. So if my example is tall people can reach the roof, my counterexample is tall people cannot reach the roof. And again, because if I talked about short people or some who were tall and some who were short and said in that group they can't reach the roof, well, then you'd say, hey, you haven't convinced me that tall people can't reach the roof. I'd have to prove to you or show you that tall people cannot reach the roof. So the counterexample of if P then Q is if P, I still have to be in the same group of things, then not Q. That little squiggly line means not Q. So let's check this out for this specific question. Now, I'll give you a few more examples in a second, and then I'll also give a little explanation about triangles. It says, if a triangle is in set A, if it's in set A, then it is not isosceles. So in order to have a counterexample, I need if P, then not Q. So I still have to be in set A. I'm still talking about set A, because I want to show that what you said before, if set A not isosceles, I have to show that's not true. So we're still in set A, still if P. Now I want it to be not isosceles. Well, something that is not isosceles, that means it is isosceles. So the counterexample of if P then Q is if P then not Q. The counterexample of if it's in set A, it's not isosceles, is if it's in set A, it is isosceles. It's not isosceles. It is isosceles. And the only answer choice that fits that is F. It is isosceles and in set A. If it's in set A, it's isosceles. Now here's a little discussion about isosceles, scalene, and equilateral. An isosceles triangle has exactly two equal sides and exactly two equal angles. That's isosceles. An equilateral triangle has all three sides equal, and all the angles are going to be equal, and they're equal to 60 degrees. That's an equilateral triangle. And a scalene triangle, which I always have trouble drawing, one of my sides doesn't even look like a straight side, it has three sides that are different and three angles that are different. None of the angles are the same. So that's a scalene. I'll just mark the angles. That should have 3 tick marks in it. So in a scalene triangle, all three sides are different, all three angles are different. In an equilateral, all three sides and all three angles are the same, and all the angles are 60 degrees. In an isosceles, exactly two sides are the same, and then, of course, two angles are the same, the angles opposite those equal sides. So that's what we were looking, or that's what we're looking at when we talk about the triangles here. But again, if P then Q, if P then not Q. If in set A not isosceles, The counterexample is if in set A, not isosceles. In other words, it is isosceles. And that's what F is. G says it is scalene and in set A. Well, a scalene triangle is not isosceles. So G is the original statement. If in set A, it is scalene. It's not isosceles. H says it is obtuse and not in set A. Well, an obtuse triangle an obtuse triangle can be isosceles. Obtuse means it has one angle that's bigger than 90 degrees. Well, that could look like this. It's got one angle bigger than 90 degrees, and two of the sides are the same and two of the angles are the same, and the other angle is bigger than 90 degrees. All right, that could be obtuse, but it doesn't necessarily have to be isosceles. So H could be a counterexample in certain cases, but it doesn't have to be. This says must be true. And we can find, with H, we could have an obtuse isosceles triangle. We can have an obtuse triangle that is not isosceles. We can have an obtuse triangle that looks like this. Boy, I just went through the wrong example there, but that's okay, because now we'll go through the right example. We have an obtuse triangle that is not isosceles. It could look like this. So it's got three different sides, even though one of the angles, and three different angles, of course, then, and one of the angles is greater than 90. That's an obtuse triangle that is not isosceles. That's an obtuse scalene triangle. So H could be just the original statement, if P, then Q. If it's in set A, it is not isosceles. It's obtuse. It's an obtuse scalene triangle. That could be true for H. H could be an isosceles obtuse triangle, but it doesn't have to be. And this one says must. It doesn't say which one could be true. H could be true. It says which one must be true. H could also be not true, not a counterexample. In other words, H is just if P, then Q. It's in set A, and it's an obtuse scalene triangle. That could be H as well. So that doesn't fit the must. J, it is scalene and not in set A. Oh, I'm sorry, H is not in set A. Boy, I'm going on and on about things that aren't true. H says not in set A. If it's not in set A, we can't say it's a counterexample of our original statement, because the original statement is if in set A. So if not in set A doesn't tell us anything about what's in set A. If people wear coats, they don't get cold. Okay, now I'm going to tell you about people who don't wear coats. Well, that can't be a counterexample of people in coats not getting cold, because you said this person's not in a coat. You're not telling me anything about those original people. So again, if we're saying if P, then Q, the counterexample has to be if P, same group, and then not Q. Boy, so I missed that with H. I wasn't reading. I did that purposely. I purposely didn't read the not originally, so I could show you how you have to be careful in reading all the words. J, it is scalene and not in set A. Well, if it's not in set A, that's not if P still, so that's not right. And then K, it's not in set A. That's also can't be a counterexample, because our counterexample has to be still in set A. So again, the only one that fits the bill here is it is isosceles and in set A. If set A, isosceles. In other words, if P, then not Q. Our original one was if P, if set A, not isosceles was Q. Here's our Q part. This is our P part. So in order to have a counterexample, we need if P, then not Q. If set A, then not isosceles, or in other words, isosceles. So that's why I was going to say, oh, it is F. I was going to say A. That's why F is the answer. It's in set A, if P, and it is isosceles, not Q, not isosceles. So that explains it. And then we also gave a little review of isosceles, equilateral, and scalene. That is all.